Welcome to today's webinar with the title Miniaturization, Mechatronics, Microvia, SLIM.flex PCB Sample, WE.scope. I'm Andreas Schirp, your host of today's Electronic Circuit Board Technology webinar, and I would like to welcome you. The speaker in today's webinar is a qualified specialist from Electronic Circuit Board Technology, Michael Kress from our Technical Project Management. Welcome back, Michael. And now I wish you lots of fun and new information.
Welcome from my side. My name is Michael Kress. I'm since 1996 working by Electronic in the 3D technology for pure flex and rigid flex technology. Today I will show you a lot of things about our SLIM.flex physical PCB sample. What do we see? What is our remember about this one? Materials, stack up, what is the design, what we do, and wire connection. And very important for me is the handling from your side or for the assembly processes. I hope I have a lot of information for you and a lot of ideas. At first, the idea was to demonstrate the mechatronic for a miniaturized application with sensor, image processing and lighting, included various interfaces from out sensoring or other things. Here, for example, our idea was installation in a handle, small housings or other housings where you have very less places for electronics. At first, I will show you the sample from the top side. Here you see a component area. On the bottom side, we have the footprint from a BGA component, pitch 0.35 millimeters. And on the top side, we use a FR4 stiffener. This stiffener material is every time for you. You can use it or not. And here we can use it from a material thickness from 0.1 millimeter up to 1 millimeter or more. Every time if we have requirements about this one, we can look what we have in our material stock about this one. On the right side you see the BGA component, and from the solder paste printing, here normally we use step pencil is an option, but I will show you option for soldering processes a little bit later. On the other areas on top side, we see ZIF contacts for SLIM.flex with 4 layers, specified for contact thickness of 0.2 millimeter or 0.3 millimeter is possible too. This is achieved by a specific material thickness and the copper areas in the individual layers. Here we can make stiffener materials or copper areas or not copper areas, and here we can handle the thickness exactly of the requirements from the contact components. And we see a snake flex, where this is very good to bend in all direction, in your shape or housing or other things, and so this is very easy for the bending. On the middle of this, we show you impedance. For this, we have an embedded coplanar strapline with impedance from 50 ohms. And here we make the impedance calculation from the inner layer. So the flexibility is very, very high. And here we use no reference layers, but every time we can look what is your requirements about this one, and here we can calculate all impedance, what do you need for your application. And here we use 50 ohm single-ended for antenna structure. In some cases, the target impedance are with different reference layer or with different materials or other things. Every time, if you have requirements about this one, come to us and we look what we can do for you. In the stack up, here we say in the design 1, a local stiffener with FR4 material. I say before, here the stiffener material we can use from 0.1 millimeter up to 1 millimeter, and normally we have the material steps every 0.05 millimeter, 50 microns, so you can use it with 0.1 millimeter, 0.15 millimeter and so on. In the design 2, here we use very often a FR4 solder carrier. Why? The PCB thickness is very thin, and for the assembly processes, for handling, it is easier to work with a 1 millimeter or 1.2 millimeter material PCB. And here we use this FR4 solder carrier, perhaps 0.8 millimeter, and here we glue the delivery panel in the outside on the FR4, but the PCB directly is not glued on the FR4 stiffener. And so you can make the assembly process, and then you can snap out the PCB from the delivery panel, but there is not glued on the carrier. In option 3, you see the wire connection. Optimally, only laser drilled microwire connections from 1 to 2 and 2 to layer 3, and from layer 4, bottom layer, to layer 3. Here we say optimal is no mechanical drilled wires, also no plated through-hole wires. Why? This is very good for very small connections, small pad sizes, for good in the design for small line and spacing, 75 microns. And if you use this, then the copper thickness are very thin, and so it is better for bending applications, for small bending applications. If you but use perhaps components would use plated through-hole wires, then normally we have thicker copper thicknesses, and then it is not possible to use the very fine line design layout. Here we need minimum 100 micron isolation distance between the lines, and the copper thickness are thicker. Normally we come to 35 microns, and so the bending possibilities are a little bit less about this one. So what is the optimum for design in this structure? We show you in the sample from our SLIM.flex PCB BGA component with a 0.35 millimeter pitch, and here we can use the design rules for BGA pad diameter 210 microns, a solder mask web from 70 microns, and a solder mask clearance from 35 microns. And here we use a laser drilled microvia from diameter 85 microns, and we can use in the design on all layers, top layer and inner layers, from 75 microns line and spacing. And the production for this PCB is the anylayer technology. Every layer we press separately on the next step, and so we can use stacked or staggered microvias. From the calculation, it is very easy. You have a component pitch 0.35 millimeter, and the pad diameter is 210 micron, minus the solder mask web with 70 micron, and minus 2 step 35 micron solder mask clearance, and so in summary you get a BGA diameter from 0.35 microns. Here you see a 3D picture from this component if we use here. And so you see stacked microvias from the top layer up to the bottom layer. The next step is for BGA component 0.3 millimeter. And here it is very more difficult to use it. And here we have two steps. Here we can go less, and to calculate this I will show you. The pad diameter is a diameter from 180 microns. The solder mask web is 50 microns. But the solder mask clearance is from the process the smallest. It is not more possible at the moment. So here we use as the same as before, 35 microns. But here the BGA pad is smaller, and so we can use a smaller diameter from the laser drilled microvia. We go less to 60 microns. And so we have the same with very thin copper thicknesses, and here we can use two 75 microns line and spacing on all layers, top, inner layer and bottom layer. So here I will show you a picture from a micro section 8-layer SLIM.flex, and here you see from the inner layers stacked microvias copper filled, a BGA component from 350 micron, also 0.35 millimeter. The solder masks steps with 70 micron, and the electrical distances between the inner layers are between 20-25 microns, and all copper thickness on the inner layer are 18-20 microns, and on the outer layer we use normally 30 microns. And here you see for this 8-layer PCB we have a thickness overall from 415 microns, we say 0.415 millimeters. On the next slide we have stiffener materials. On top we have the option for local stiffener made from FR4 material to do partial rigid parts. Normally our customers use this in the component areas to make the PCB a little bit thicker or more stable for mechanical. And on the option 2 I come to is the FR4 0.8 millimeter FR4 solder carrier. Here we can use this only for follow processes, for assembly process, soldering process and so on. And after the snap out the PCB from the delivery panel, there is not more on the PCB. So now I will show you a short video from our sample to the delivery panel about this one. So the contour is laser milled with small micro steps, and then after we lift with a pin about the PCB, and then you can remove the PCB very easy from the delivery panel, and so you have a very thin PCB, and the assembly process is very rigid parts. For solder carrier, you have option to use it a step stencil at first. If you use a FR4 solder carrier, the option is you can only make assemblies components on one side, perhaps on the top side. If you will use this on top and bottom side, then it is more complicated. So it's very important to involve the assembler in order to coordinate the possibilities of the processes to set the components and soldering this. We have different options. At first, we can use a step pencil from bottom side. Here we open the FR4 carrier, and then you can use a step stencil. or you can use a dispenser process to set the solder paste on the SMD areas. Or other option is we make an optimized frame FR4 stiffener. So here we make only on the frame on the outside, not a PCB directly. And this is very, very thin. And so we can use this for frame in your assembly process and soldering processes. But every time, I say before, it's very, very important that we discuss this with your assembler. And here we help you every time to discuss these options, what is possible and what we can do and what can the assembler do to make the very good process in the assembly and soldering processes. So, summary from my side, SLIM.flex PCB samples is a very good solution to get you a hardware in the hand and to check what is possible. SLIM.flex and SLIM HDI technology offer high free from new applications in small housings or bendings. You can use different stiffener materials with different material thicknesses. You can use the FR4 solder carrier to make optimized assembly processes. And if you need more information about SLIM.flex technology, every time you can look to our website. And very important, you can order this SLIM.flex sample on our homepage. Here you can order this and then we send you 1 or 2 PCBs directly to your home, and then you can make a lot of tests, or you can look what is the handling about this one. And if you have questions every time, come to us and we will help you in your application, in your project. And so I hope we can find a very good solution for your project. Very thanks for your attention.